Hello, and welcome to this OpenTopography tutorial. Today I will be discussing dataset reprojection and a very common error when doing dataset reprojection. So here we are in central Idaho, and now we're looking at a topographic hillshade that has been created from USGS 3 data. Here we're looking at a mountainous landscape with the light angle in this topographic hillshade coming from 45 degrees, so from the northeast. That's why we see some of these mountains, particularly on the north-facing slopes with these lighter colors. And here we are in UTM zone 12. And I can make a different video describing in more detail what a UTM zone is. But here we are with UTM zone 12. And here we're also at the boundary very close to the UTM zone 11. And so if we're looking at topographic differencing or for some comparison of data in a nearby spot, we may want to project this data set to UTM zone 11. So let's look at how to do this. So first we're going to look at the data itself and at the metadata. So you can first click it, and then here we have the information. And I always do recommend that you look at this document, this information. For example, you can see the extent that will be written in the coordinates system of the data. You can see the width and height of your raster dataset. You can come here to pixel size. So you see that our data is at a 1 meter resolution. And then particularly relevant for today is we have the coordinate reference system. This is often abbreviated as CRS. And this data set that we have here has an EPSG code. EPSG stands for European Petroleum Survey Group, and each coordinate reference system, at least the far majority of them, have their own EPSG code. And here we can see that our data set is in UTM zone 12 north. So this means that the data set has units of meters. But again, we may be interested in reprojecting this data set, for example, to UTM zone 11 for a variety of applications. So let's look at how to do that. So we're going to be projecting this data set, so we want to have it highlighted. And then we go to raster projections, warp/reproject. So raster projections, and then warp in parentheses reproject. All right, so here we have the options that we can set. So we have our input layer, which is data UTM 12. The source CRS, so that's the CRS of our original data. And often the top option will be the project or default CRS. And again, you do want to check that we're selecting the correct option. And we did just check that our data set is in this UTM zone 12 with the EPSG of 32612. And then we have the target. And so we want to put it in UTM zone 11. So we'll click this button here. And then we have options, so we can click here and we'll say predefined CRS. And option 11 is here because I had clicked it before, but if it's not, you can type 326, which sets you up for and then entering the UTM zone 11. So we'll double click that, and then we'll go back to this arrow. And we have the source and target. We'll be taking our data set from 12 to 11. And we can't leave, at least for now, the default of the nearest neighbor for the resampling method. And then we can save our file here, reprojected, save to file, and we'll call it data UTM 11 nearest neighbor. And then for the nearest neighbor, our interpolation method, we'll say save and run. And now it's running. this at the top. So here is our data set, and let's make a hillshade. So be sure to select it. We'll say raster analysis hillshade, and we'll put it at 45 degrees to be consistent with what I had before, to be perpendicular to the mountain front. So we'll say run. Close. All right, so here is our topographic hillshade. Now when we zoom in, you'll see that the hillshade now looks very blocky. In particular, we have those almost north-south and east-west lines in the data. And this actually reflects our choice of nearest neighbor, because the nearest neighbor takes or replicates those nearest pixel values, but doesn't apply any sort of smoothing. So you'll get these linear boxes in your data, these aligned boxes. So let's try this again, but we're going to use a different interpolation method. So we'll remove this hillshade. And again, we want to select our UTM data, our data in UTM zone 12. We'll go raster, projections, and then warp or reproject. So again, that's raster, projections, and then warp. We'll select that. Then we want to select the same options we had before, at least for the beginning. So our source CRS is going to be UTM zone 12. And then we want to reproject to UTM zone 11. And now for the really key part, this is where our setup differs from last time. So previously we had the default of the nearest neighbor method, but again, that generated those boxes in our data. And to not have those boxes, you can select a bilinear method where it does an averaging. You can come down. We'll save our data to a file. So we'll call this data TM11 bilinear. Save, run. All right, say close. So here is our data in UTM 11 bilinear. We'll put that one at the top, and let's make the hillshade. Again, that's raster, analysis, hillshade, 45, and then we'll just say run. I didn't input a file name to save it to, so it is just saving as a temporary file. Close. All right, so now we have our hillshade, which is the hillshade of DEM within the reprojection following the bilinear method. And we can zoom in, and we don't see those boxes. So in summary, when you're doing reprojections of data sets, it's really important to not use the nearest neighbor, and the bilinear option will work quite well. Thank you.